Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good. Last session we started investigation of performance impact of what is it? Init height data in the height map. So we identified a few things that we can potentially optimize and update vertex buffer. Right now, we also have we have around like, I don't know, 20%, 15% of time is spent here with allocation events, reallocation. I wonder what we can do there. It's this one here. These ones, the reallocations top here. Up here is a deletion. So here's, it's weird that it shows deletion here. Yeah, good. So how can we optimize this? I don't know. What I do see here is that memset 32 is really expensive as well. Memset 32. Memset. I remember I already noted that in the past. Memset 32 fills memory with a 32-bit value. Assumes the pointer is 4 byte aligned. Memset 32 assumes the PTR is 4 byte aligned. Okay, but this is for debug. Okay. That's for debug, right? Debug. Yeah. Yeah, it looks like it's exclusively used for debug, so it's not a big concern. That's 32. But could we still optimize this? Bytes to fill. Bytes to fill. Value. Memset. This one writes bytes, right? SD memset. In CH. Copies the value. Oh. No, it's a 1 byte value. I would assume let me ask here. Is Memset optimized? Does Memset do typical implementations of Memset use what's it called, SIMD to write the bytes? Typical implementations on yes, high performance implementation Memset almost always use SIMD instructions, but only after handling alignment and size thresholds. These are typically in modern Memset. Straightforward scalar. This avoids overhead from setting up SIMD registers. SSE, AVX, move, vector stores. Many implementations include multiple versions and dispatch based on CPU features. Limits 2 bytes, AVX stores for large regions. Align the destination to the SIMD width for large chunks. Zeroing is even faster. SIMD, SSE2 universally. Maybe the simplest fix here is to just use Memset. What does this return? Size T. But the only problem is it doesn't write 4-byte words. Is there a Memset implementation that allows to write 4-byte words? 4-byte words instead of 1 bytes. Several Memset variants. Memset 32. Linux kernel, BSD. SIMD optimized 4-byte filling. Compilers generally auto-vectorize this. Dead beef. I mean, that's what it currently does, right? What about the following implementation? implementation. Will that be vectorized? Vectorized. No, not auto-vectorized this implementation. Non-canonical. Old school Duff's device idiom. Okay, how about we take this implementation and we open Godbolt. Godbolt compiler explorer. Okay, then we delete this here and this. Mapset 32. And that one suggested this one here. Let's take that bullshit. I take here int value. Take here unsigned char. Let's see std int. Okay, let's see. So this is optimized, yeah. So what is about this? Static voids. So this is version 1 and this is version 2. Okay, then we do a char. It's a void p. Let's do int p new int 500, and then another one p1 p2, and then we do a memset 32.1 p 0x 1111222 bytes to fill 500 times 4 memset 2 p1 p2. There we go. Good. Let's see. So memset 1 is this one here. Yeah. Memset 1. Memset. Where's memset 2? Memset 2 is down here. Oof. Oh, that looks. Oh, it didn't compile. Ignoring unknown option. O2. So memset 1 is up here. It does looping, yeah. Tests. Jump. Where does it jump to? LN4 here. And this one jumps to LN7, as you see here. LN4. Is it looping or not? Here, jump memset. Where is this jumping to? What is this? I don't know where this is jumping to. Jump memset. It looks very similar to this one here. It looks pretty much identical. Yeah, I don't see much difference here in this. Yeah. I think we just need to use it so that it compiles it in. Oof. Okay. This looks like it just creates a long table instead of a loop. Yeah. Yeah. I can't tell what is faster here. It looks to me in MSVC it looks exactly the same. Yeah. I don't see any gain here. Memset 32. this one here is a loop. Big loop. LN17. Okay, this one is definitely a loop here. Add RCX16. Compare. Okay, so this one here, this is the first loop, this here. And this down here. This one is the second loop here, this guy. Or is it not? Program looks weird. Yeah. It looks like these two functions are inlined here in this main function. Yeah. It's inline and this is inline. That's why it's here together. Okay. Okay, so it essentially unrolled this loop here in this version. Here it did not unroll it. It actually means these are more instructions because it writes 4 words per iteration here in this one. So this loop looks to be more expensive, and here it writes 16 bytes at once. Right here. So this in Clang, indeed, this is more efficient. Yeah. How do we enable SE to or AVX to in MSVC? Arc SSE2. Okay, let's try that. Okay. So here we have this, yeah. Test. Here it uses it in this loop, but not in this loop. Okay, but it seems that this implementation indeed is a bit more efficient. Yeah. Value bytes to fill 4 words. Words to fill. P. Why don't we just put this here? This here. Then here we do I equals size of int bytes. Let me ask, how about this implementation? The tail loop has a bug. P1 is wrong. You're indexing the tail buffer. Sorry, what is the bug? P1 is wrong. You're indexing the tail buffer using global byte offset. What? P, B. I don't understand what the problem is. PI is wrong. You're indexing the tail buffer using the global byte offset. What? The global byte. BI is wrong. You're indexing the tail buffer. Then how about we just do it like that? How about this? Okay, let's add a compiler can vectorize this. Filling the tail. Filling the remaining bytes. Mm-hmm. Mm-hmm. Okay. Is at least. Static assert. Size of voids larger equal 4 bytes. Well, 2-byte pointer. 4-byte monkey. Oh, what that? There we go. Monkey CPU. Okay. Good. That didn't do all that much for us. So the allocation. How can we get rid of the allocation? Yeah, that's the big question here. Init height data. Init height data. So it's this one here. Requested height map different from old one. So now vertex. How big is this? 32. 32. Times 2. 32 times 2. 64 times 64. Okay. 64. And how much is this? Non-VB tires. Tire length. X. Also 32. The same value, okay. How big is this X here? confused by this. Why does it do this loop here? What is this? Why is this looping? Shouldn't this just be a calculation? So J is that. So it means if x is I. What? Yeah, it's probably just a few iterations. Maybe it's nothing we need to worry about. Yeah. Oh, let me ask. Can you rewrite? Can you rewrite this without looping? X plus that minus 2 divided. That's really counterintuitive. Minus 2. Clamp to at least 1. Can I what's 1, 2 plus would that also work? No. Oops. Well, that's too bad. It's always too big. One. Okay, then let me ask again. Oh, I just realized I typed it wrong. That one should have been a 1. How about this? Okay. ChatGPT is happy with this one. So x minus 1 divided by this x minus 1 Okay, good. Let's roll with this, and this would be a bit better. Okay, how do we get rid of this allocation? We need to either keep a larger allocation or yeah, vertex buffer backup. Tired. How about we need to somehow get rid of this shit. I don't know how. I don't know how. we can... Oh. We always reallocate. We shrink or we grow it. Shrink or grow. How big is this vertex format? Um, 8, 16, 32. Num vertex. So this is num vertex 32. This one is 32 times. Let's get a calculator. So this is 32 times wait, so 64 times 64 times 32. So that one is 131,000 bytes, which is divided by 1024, 128 bytes. So one of these is 128 bytes, kilobytes, 128 kilobytes. And how many do we have in here? NumVB tiles. So this one is X. So this one starts as so that one is 129 minus 1 divided by 32. Oh, that doesn't look right. 128 divided by 32, 4. So we have 5 of these, 5. And so it's 5 times 128 kilobytes. So 640 kilobytes. It's not that much. Is that correct? X. This one is 32, right? Yeah, 32. So X minus 1. So 5 times 5. 5 times 5. So it's 25. 25 times 128. 3.2 megabytes. It's also not that much. I still don't understand why this is so expensive, this allocation event here. I mean, this is really not that much here. Obviously it grows, so if we have twice, yeah, if Let me run a test here. Let's stop debugging. Okay, that's 1, 2. I expect the stops at 5, right? 4. Only 4. Okay. Okay, then this is wrong. Well, that's wrong. Then maybe it needs to be like this. But then that could become 0. What do we say? Min 1. Max 1. Max 1. Ask ChatGPT. How about this? Not quite. Underestimate by 1. 1 plus. But that clearly doesn't yield the same results. So ChatGPT is not correct on this one. Seal. Seal. Max 1. Let's go with the original loop for now. It's not expensive here, so I guess it's fine. Okay, but I'm still not sure. I still don't understand how. Is this symbol known here? No. I would like to say here 1 plus 4 times this. Includes height map. Height map. Oh, this one includes world height map. Oops. Oof. Tile data. Base height map. Okay, so how about we take this guy and we put him into here. Yeah. Makes a bit more sense, doesn't it? Okay. $16. Num vertex. 4,000. Yeah. Okay, does the game still work actually? Let me merge the one optimization we did in here. Need to be careful here. We don't include a unrelated change. Is that it? Optimize repeating calls to this and this. Update VB, update VB, VB for light optimized. Okay, that's step number one. Optimize memset 32. Okay. So what happened here? What is this? Huh? I have no idea what happened down here. I have no idea why this line has changed here. I didn't touch it. I swear. Okay. Good. So I'm still none the wiser. How do we avoid this reallocation? Vertex buffer tiles, num vertex. Use. Num vertex. Buffer class. Vertex buffer. Vertex buffer. There probably is some way we can do this, but it doesn't come to me right now. Um, so we could say if we have over allocated, we just use a smaller subset of what we have room for, right? So that would work. But then that means we always carry a larger allocation with us, right? Go as a preset material for now. There must be some way. We want to use a buffer. Use a buffer. Would it maybe help to make it one allocation event? Like instead of doing multiple ones here in this loop, we just create one big buffer and then we just manually index it. Because it seems a bit silly that we need one array here to just store another array, right? Why don't we just have one flat array for each of these types? Yeah, that I don't understand. We can allocate. Is it possible to allocate a multi-array, multi-dimensional array in C++? I don't think so. Stack heap. Yeah, okay, but this is pointer to pointer. Yeah, but this is not what I would like. Single contiguous block. Yeah, rows times calls. Memory is contiguous. Better cache performance. Access is slightly less readable. Yeah. Yeah. So we have one, two, these two. These two. So we could reduce this to one allocation. This one and this one. What two allocations. Down from 1, 2, and then here's 16. So that's 32 allocations. This number was 16, right? Yeah, 4 times 4. And then this one is one allocation. That's fine. So maybe that would help if we get that down from 18 allocations to 2 allocations. Maybe. Yeah. We can try that. Yeah. It would require a bit of refactoring. So we would do that and that. And then we would find all references to this guy. And then we would do... Then here we would do a delete. We will remove all of this here. There we go. There we go. I don't know why this one here is complaining right now. What is this? Inaccessible? What? What is this? I don't know why this is here complaining. It doesn't make any sense. Let's ignore this for now. Plus J. Plus J MP. Plus J. Okay, let's look at this later. So here we would do num-vertex, this tiles times your ref. So this one is new times this. And this one is this times yeah, how do we allocate this guy though? I don't know how we can allocate this guy here. No default constructor. How can we allocate an array of a C++ class that has no default constructor? Do we need to use placement new? Fails, yes. Placement new. Okay. Then we allocate with new can't use new. Can we still use new to allocate the raw buffer without constructing? How do we do that? Operator new. Aha. Okay. Let me say operator new, yeah. Operator new. Will this work? I don't know. What is this doing? New. That doesn't work. Times size of that doesn't work. That doesn't work. Okay, and then we would have to loop through this, yeah, and do placement new on these guys, which is oh, and then we also need to destruct manually. So essentially we take out this guy and here we do a new this tiles this, and then we do a new ref. Now we take this that doesn't work. Why not? No instance matches the argument list. Unsigned int. Buffer class. Maybe because it has this glue here. Yeah, maybe we cannot construct it like that. Yeah. Can we construct it with other means? New ref. New ref. Would that work here? Don't think so. Yeah. I don't know how we can place this in one buffer. I suspect it doesn't work because of this stuff here. This one. Any other way? There must be some way. Yeah. How do we add a placement new operator to this macro? Size pointer. Okay. Delete. Placement new. It means it won't go into the mempool, right? Yeah. I can try that. placement. No except we go to CPP macros. No except we already have that. 17. How about we say define no excepts. Okay. Okay, would this work? Yeah. Okay. So this means we now place it on a custom buffer. We don't use a memory pool. Yeah. For better or worse. Yeah. Okay, so this would work, yeah. Okay. Then we do the same here. It's a different format. Okay. Okay, so that will be the allocation event. The deallocation we already have, but it's not complete. We also need to destroy it. So we need to do... Yeah, this one we don't need to destroy, but this one we need to destroy. Or not? Oh, the destructor is inaccessible. Oops. Right. Right. Operator delete this. Is that right? Then we do this here for this, and then, well, now the question is, can we actually destroy it? Oops. We can't destroy it, right? Can we do that? inaccessible. Yeah, that's shit. How do we destroy this? Hmm. I don't know. You can't destroy it. But we need to destroy it. Otherwise this will leak. Well, I suspect the constructor is... Well, it is public here. But this one is protected. That is virtual. Can we do a static cast? Static casts to this here, yeah. Static casts. Yeah, and then call this. Will this work? Hold on. There we go. that will work. Oh, that's funny. Okay, it's quite a bit of a hack, but actually, this is yeah, it's probably fine. Yeah, I think this will work. If not, we will see. Good. So this will this will totally bypass the the memory pool. Yeah, but we don't care. We don't want a memory pool. Okay. So this looks good. Then we still have... We still have this. So, vertex buffer tiles. Point to correct row column. Plus J times that plus J. What is this? Should be like that. Oh no? Charm. I think that will work. Yeah. Then we do the same here. Why don't we just move this down? Okay. I leave it here. Let's put it here. No, I don't understand why we need to put it there though. That doesn't make sense. Let's put it where it's used. I think that's best. There we go. Set vertex buffer. Tiles. Set vertex buffer. Okay, what is this? I think here we simply need to do that. Yeah. Okay, is that it? Yeah. Let's see the compiles and runs. I probably forgot something and everything will crash, but oh boy. Well, it doesn't compile. Place, undeclared identifier. Oh, well, that's a good start. Place. Oh, return place. Well. Yep. Let's make this a size S. Void placement. Delete. Why do we have this commented here? So, do we have compile errors? More? No. Nope. Okay, that's cool. Okay, we somehow bypassed the allocator, yeah. Quite some trickery. Well, the question is, will this still be faster or not? Maybe. It depends like how expensive the allocator is, like adding and removing things, big blocks. But maybe there's no gain at all. It could also be, right? Okay, let's run this, see what happens. Doesn't crash so far. Okay, it does work. That's good. Let's load some map. Okay, so that works. Let's see the lag. Okay, it's still lagging. Of course. Let's make a new recording and see if we made any gains. How do we record here? Diagnostic here. Record CPU profile. Let's go. Okay, we go up and down. Okay, that's good. Okay, break. Now the question is, how do we get there again? I don't know. Events, no. Yeah, the question is, how did we find this the last time? The function list. I can't remember. Ah, here. Or search. Oversized terrain. There we go. There we go. Flame graph. Oof. Oversized terrain. There we go. Okay. Well, allocation and the allocation is still here. Well, we got rid at least of these small calls here. This one is significantly less, so that's good. Okay, we didn't make any savings in terms of this allocation thing, but it looks like the cost comes from memset. Oh. It comes from memset. Then maybe we don't care. Maybe we don't care. Yeah, looks like it's debug only. it looks like we don't need to worry about this because all I see down here is memset32. Yeah. So it's probably just that slow, and its debug release it will be compiled out, so we don't care. Yeah. Yeah. Okay, that's fair enough. Okay, but we can still go ahead with this optimization. For now, it works, so let's take it for now. Okay, I expect it gives a bit of performance boost. Maybe. Okay. So we take this and this. That's okay. Okay. Good. Then this is make this and that one big buffer each. Okay, and then we can also do this here. Use clamp in this. Then let's also take this here. Clarify values. Verify values. I think there was something else regarding 32. Oversized terrain. Oversized terrain. Oversized terrain. Height map. So this one uses 32 hard-coded here. Then we should also use this one, tile length. Put that here. 32. There we go. Do I have a 32 somewhere else in here? Base height map 32. There is. Not sure if that 32 refers to the same thing. Maybe it does, maybe not. Maybe. I'm not sure yet. Good. I think I will end it here. Yeah. Then I wish you a great day or night until next time. Goodbye.